Earth weighs 6 trillion kilograms. Jupiter weighs 318 times more than Earth. Add up every planet, every moon, every asteroid, every comet, every grain of space dust, and you get roughly 0.14% of the solar system's total mass. The Sun weighs 1,000 times more than everything else combined. Think about that. If the Sun were a basketball, everything else would be smaller than a marble. This isn't just big. This is absolute dominance on a scale that breaks our brains. But why? To understand, we need to go back, way back. 4.6 billion years ago, there was no sun, no Earth, no planets, no solar system, just a massive cloud of gas and dust floating in the darkness of space. This cloud was enormous, bigger than our entire solar system today. Most of it was hydrogen, some helium, traces of heavier elements forged in the hearts of dying stars. It was cold, it was quiet, it was waiting. Then something happened. Maybe a nearby star exploded. Maybe two stars collided. A shockwave rippled through space. The cloud shuddered and began to collapse. Gravity took over. Every particle of gas, every speck of dust, all of it started falling toward the center. As it collapsed, it spun faster, like a figure skater pulling in their arms. The center grew denser, hotter, more massive. This was the birth of our proto-sun. But here's the key. Gravity is ruthless. The closer you are to mass, the stronger gravity pulls. Double the distance, and gravity becomes 4 times weaker. So as the cloud collapsed, most of the material didn't spread out evenly. It rushed to the center. The proto-sun grew larger, denser, its gravity grew stronger. This created a runaway effect. The more mass it gained, the stronger its gravity became. The stronger its gravity became, the more mass it could pull in. More mass meant stronger gravity. Stronger gravity meant more mass. An unstoppable cosmic feedback loop. In just a few million years, a blink of an eye in cosmic terms, the proto-sun had gobbled up most of the available material. We're talking about 99.8% of everything. What was left over formed a thin disk around the growing sun. This leftover material, these cosmic scraps, this is what became the planets: Earth, Mars, Jupiter, Saturn, all of them. We are literally made from the leftovers. But it wasn't just planets. Tiny rocky bodies called planetesimals, the building blocks of worlds, swirled in the chaos. Some smashed together, becoming moons. Others stayed frozen and untouched in the far reaches. A vast halo of icy debris, the Oort cloud, still surrounds us, stretching halfway to the next star. It's a ghostly sphere of ancient material, a fossil of our solar system's birth. Even in the margins, the leftovers hold stories. As the proto-sun packed on mass, its core temperature soared: 10 million degrees Celsius, 50 million degrees, 100 million degrees. At 15 million degrees, something incredible happened. Nuclear fusion ignited. Hydrogen atoms began smashing together, fusing into helium. Einstein's famous equation came to life: E equals mc squared. What does that mean? It means a single gram of mass, barely the weight of a paperclip, can release 90 trillion joules of energy, enough to power a city for days. And the sun does that with millions of tons every second. It turns tiny amounts of matter into a flood of light and heat. That's the power of fusion. That's the fire in the sky. The sun was born. And it was massive, unimaginably massive. 333,000 times more massive than Earth. 1.989 times 10,000 few kilograms. Your brain can't even process numbers this large. But here's what makes it even more incredible. That remaining 0.2%, it tells an amazing story. Jupiter alone makes up about 0.095% of the solar system's mass. More than twice as massive as all other planets combined. Saturn, Neptune, Uranus, Earth, Venus, Mars, Mercury. All together, they're just 0.04%. All the moons, 0.000005%. The asteroid belt, 0.000006%. Comets, even less. Interplanetary dust, solar wind, cosmic rays, these don't even register. And us, every human who has ever lived, every building, every mountain, every ocean, We're not even a rounding error. We don't even register on the cosmic scale. Yet this tiny speck, this 0.2% leftover material, created everything we know and love. Rocky planets with atmospheres, gas giants with dozens of moons, asteroid belts, comet clouds, and somehow impossibly, life. But here's the question that should blow your mind. If gravity is so powerful, if the sun is so massive, why didn't everything just fall into the sun? Why do we have planets at all? The answer lies in one of the most beautiful concepts in physics: angular momentum. Remember that figure skater? When she pulls her arms in, she spins faster, but she's still spinning. The rotation doesn't stop. When our solar nebula collapsed, it was already rotating slowly. As it contracted, it spun faster and faster. This rotation flattened the cloud into a disk. Material in this disk wasn't just falling straight into the sun. It was also moving sideways. This sideways motion became orbital velocity. The planets aren't just falling toward the sun, they're falling around it. Earth is constantly falling toward the sun due to gravity, but it's also moving sideways at 30 kilometers per second. By the time it would hit where the sun has moved. So Earth keeps falling around the sun, forever. Each planet found its balance, close enough that the sun's gravity holds them, fast enough that they don't fall in. Earth found the perfect distance, not too close, where water would boil away, not too far, where everything would freeze, just right. And in this narrow band of possibility, life emerged. But none of this would exist without the sun's gravitational dominance. Right now, as you watch this video, something incredible is happening 150 million kilometers away. Deep in the sun's core, 600 million tons of hydrogen fuse into helium every single second. 600 million tons. Every second, 4 million tons of that mass converts directly into energy, pure energy, shooting out in all directions. Some of that energy, after an 8-minute journey through space, hits Earth. It powers photosynthesis, drives our weather, creates wind and rain, fuels the entire food chain. Every calorie you've ever eaten traces back to the sun. Every breath you take exists because plants used sunlight to make oxygen. The oil in your car? Ancient sunlight, stored in prehistoric plants. Wind power? Solar energy creating air pressure differences. Even nuclear power uses elements forged in dying stars. But the sun doesn't just power life, it holds everything together. Its gravity reaches out past Pluto, past the Kuiper Belt, into the Oort cloud, 1 trillion kilometers away. Voyager 1, humanity's most distant spacecraft, is still within the sun's domain. The sun doesn't just light up our world, it defines our cosmic neighborhood. It is our anchor in the vast darkness of space. Imagine, for a moment, the sun suddenly vanished. Earth would immediately fly off in a straight line at 30 kilometers per second. No more orbit, no more seasons, no more day and night. Within days, surface temperatures would plummet to minus 100 degrees Celsius. The oceans would freeze solid within months. The atmosphere itself would eventually freeze and fall as snow. Earth would become a dark, frozen ball of ice, hurtling through interstellar space. Every planet would scatter in different directions. The solar system would cease to exist. Jupiter might keep some of its moons, becoming a mini solar system drifting alone. But that's it. 4.6 billion years of cosmic evolution, undone in an instant. But the sun doesn't vanish. It's been burning for 4.6 billion years, and it will burn for another 5 billion. But not forever. One day, the sun will run out of hydrogen fuel. Its core will contract. Its outer layers will swell. It will become a red giant, so large it could swallow Mercury, Venus, even Earth. Then, it will shed those layers into space. What's left behind? A white dwarf, a dense, glowing ember, no longer burning, just fading, for trillions of years. The sun's story doesn't end with fire. It ends with silence. That's the power of 99.8% of the solar system's mass. That's the engine that drives everything we know. So here's the profound truth. We live in a sun-dominated universe. Every planet, every moon, every asteroid, We're all passengers on the sun's journey through space. Our entire solar system orbits the center of the Milky Way galaxy once every 225 million years. But we do it together, as one unit, held together by the sun's gravitational embrace. Look up at the night sky. Every star you see is another sun, likely with its own collection of cosmic debris orbiting around it. We've discovered thousands of exoplanets. Each one is part of the same story, a massive star surrounded by the leftover scraps of its formation. This pattern repeats throughout the universe. Mass creates gravity. Gravity creates order. Order creates the possibility for complexity. And complexity creates the possibility for life. So the next time you feel the warmth of sunlight on your face, remember, you're feeling the touch of a cosmic giant, a star that collected 99.8% of everything in our cosmic neighborhood, a star that turned nuclear fire into life, a star that transformed chaos into order. In a universe full of darkness and cold, in a cosmos dominated by empty space, the sun is our center of order, our anchor of stability, our engine of life. The sun doesn't just light up the sky, it owns the solar system, and we are grateful inhabitants of its domain.